Hello guys, welcome to Solving Solutions, your unbound channel where I get solutions to all your solving problems. It's 9th Avenue in class again today. How have you been? On today's tutorial, we are going to perform some statistical analysis on this land use land cover data we have here. So we have actually clipped it to the extent of Obiakpo boundary, and then we have also extracted the percentage, or maybe the area rather, of the different land use. Now that particular year, let's call it 2020, right? Good. So let's say that particular year is 2020, and then from the land use land cover we have there, we have clouds to be this area, bare ground to be this area, crops to be this area. So yours might not have this number of land use, or maybe these particular types of land use. However, whatever the use of land you have for maybe extracted from your land use land cover data, you can actually present them like this. Now the first thing we want to do is that the area that was extracted was actually in a meter squared, right? Good. So we have the pixel count and the area in meter squared. So we first of all converted the area in meter squared to hectares, right? Good. So that's simply divided by 10,000. So we divided the area we have in square meter by 10,000, and then we have the equivalent in hectares. The next thing is that we want to get the percentage area, so that simply we have equal to, and then we open a bracket. So we want to say each of the value we have here divided by the sum, right? Good. So we actually have a sum here. The sum comprises of all the values in hectares that we have here. So if we also want to use that of the square meters, we can also use, but since they are equivalent, just that the units are not the same, right? Good. Then we have to lock this particular cell, so we introduce the dollar sign so that we can lock that particular cell for cell referencing, right? Good. So when we have done that, we now close our bracket and then we multiply by 100. So this gives you the percentage area covered by clouds. So we can just decide to drag and drop. Okay, let's bring it down to this point. Now the reason why we are seeing 100 is that it's telling us that all the values we have here, they all are equal to 100. So that's a check to know that your percentage is actually calculated correctly. So we have the highest to be built up area, followed by vegetation, then flooded vegetation, water, rangeland, crops. So as we said earlier, your own land use might not be the classes that we have here. However, this is the procedure you are going to follow. Now you can do that for 2020, 2021, 2022 and 2023. The next thing we should look at is a bit of visualization of the different land use classes. So let's say we are going to highlight the land use and also the area in hectares, right? Good. Then we come to insert. Now from insert, we can decide to use the column or bar, right? Good. So now let's start with this, which is the clustered column. So if we use this, we are going to see a very good visualization of what the particular year that we are studying, right? Good. So it's obvious that the built area is actually having the highest column. So it's very easy to visualize, right? Good. So similarly, we can also use a pie chart to represent that. So let's just take this out and then let's insert what a pie chart. So we have this, and then you can also see by using the pie chart what we have as what the different classes of what land use. So you can hover your mouse around there to see different formats and then select from which of them best fits your visualization curiosity, right? Good. So these are different formats. So basically we have shown you that. We have also shown you the visualization. Then we also have a second sheet where we have arranged our data in a vertical format, right? Good. So we have all the years in a particular column. We have the different land use for the different years. We have the pixel counts, their areas in meters squared, and then their areas in what hectares, right? Good. So we have also decided to calculate the percentage change, that's the change between the oldest and the latest year, right? Good. So we have 2020 and then we also have 2023. So it's simply subtracting this value from this value, right? Good. So that's why we have negative answer, because if we open this formula, it's actually L minus I, right? Good. So that gives you the result for the change in background over this period of time, right? Good. So you now see we have negative change. For the built area, we have positive change downwards, right? Good. Then finally we have the percentage change that has occurred over the period of maybe 3 years, right? Good. So we are looking at 2020 to 2023. So this is the percentage change that has occurred over this period of time, right? Good. So we have shown you basically how you can get maybe the percentage area, how you can visualize using maybe bar charts or pie chart. There are different visualization tools that you can explore here just to give your data a very good presentation. Then we also went ahead to use the pivot table to format this our data to have this column data, maybe a very straight data. And then we've also shown you how to get the percentage change of the beginning and the ending years, so that you can see the extent at which maybe the land use of the built up area, if it is increasing or if it is reducing, and then it can inform your decision making. So thanks for coming to class. We hope we have shown you how to carry out a few statistical analysis from this land use land cover data you have, so that you can derive insights from this particular data. So we are going to see you on the next tutorial. Ensure you keep staying safe and have a fantastic time. Bye.